This is a video on applying L'Hopital's rule to limits that involve exponents. The question is to evaluate the limit as x goes to 0 from the positive side of the quantity 1 plus 2x to the 3 over x. And to do that, the first step is to plug in, and if I plug in x equals 0, I end up just getting 1 plus 2 times 0, that's just 1. And then 3 divided by 0 goes to infinity, and 1 to infinity is one of the indeterminate terms. So I apply a trick, and the trick is as follows. I apply the natural log to both sides of the equation. And one nice thing, the natural log is continuous. So the natural log and the limit can get interchanged. So I have now the natural log of y is equal to the limit as x goes to 0 from the positive side of the natural log of 1 plus 2x to the 3 over x. The purpose of this is when we have an exponent, the natural log simplifies. We can use the power rule for logs and bring the 3 over x over. And what I get is the 3 over x and then times the natural log of 1 plus 2x. And now it looks more like a L'Hopital's rule question, because when I plug in 0 now, natural log of 1 plus 2x is natural log of 1, which is 0. 0 times 3 is 0. So I get 0 on the top, and x is 0 gives me 0 on the bottom too. And I get 0 over 0, which is a form for L'Hopital's rule. So that means I can take the derivative of the numerator and the denominator and still take the same limit. So I do that. The derivative of the numerator, I use a chain rule. The derivative of 1 plus 2x is 2. 2 times 3 is 6. There's my 6. And the derivative of the natural log function says take 1 over what's inside. So I get 6 over 1 plus 2x. And then the derivative of x is just 1. And that's very good because now when I plug in, if I plug in 0, I get 6 divided by 1 plus 0, or 6 divided by 1, and that's just equal to 6. So what I have now is the natural log of y is equal to 6. So I could find y, which is our goal, by just exponentiating with base e. And when I do that, my final answer is e to the 6th power, and that's the limit that I'm looking for. And I'm done with the problem.